So, what's up, students? Welcome to this virtual session where, while dealing with the reflection of light by spherical mirrors, we shall follow a set of sign convention called New Cartesian Sign Convention. In this convention, the pole P of the mirror, this is P, this is pole P of the mirror is taken as the is taken as the origin. I repeat, the pole of the mirror, that is P, is will be taken as origin. The principal axis of the mirror is taken as the x-axis of the coordinate system. Now let's start with the sign convention. What signs you should follow while calculating the numericals based on the reflection by the spherical mirrors. So first sign convention is that the object, this is the object. So the object is always placed to the left of the mirror. See, this side is the left side of the mirror and this side is the right side of the mirror. तो हमेशा ऑब्जेक्ट को कहाँ रखना है? हमेशा लेफ्ट साइड पर रखना है. This means that the light from the object falls on the mirror from the left hand side, and all the distances parallel to the principal axis are measured from the origin. What is the origin? The pole of the mirror is the origin. So all the distances will be measured from this point. Okay. Now see, next is all the distances measured to the right of the origin. ये right side है ना? So all the distances measured to the right of the origin are taken as positive. तो जो भी डिस्टेंस आप यहाँ से राइट साइड में चलते हुए कैलकुलेट करेंगे उसको हमेशा पॉजिटिव में लेना है. एंड दोज मेजर्ड टू द लेफ्ट ऑफ द ओरिजिन, दैट इज पोल के लेफ्ट से जो के तरफ चलेंगे और उसको मेजरमेंट करेंगे तो they will be taken as negative. I'll read from this also. The distances to the right of the origin is positive, while that to its left is negative. Okay. One more point you have to remember is that the distances above the principal axis, this is the principal axis, प्रिंसिपल एक्सिस के ऊपर जो डिस्टेंस आप कैलकुलेट करेंगे दैट विल बी पॉजिटिव. द डिस्टेंसेस अबव द प्रिंसिपल एक्सिस आर पॉजिटिव while the distances below the principal axis are negative. Okay. Again, this is light will fall from the object to the mirror. So the distance of this light, the whole distance covered by the light will be measured in the negative, because it is we will be measuring distances from its pole. So pole के left में है, then the distances will be negative, and if the distances are from the right side are in the right side of the mirror, then they will be considered as positive. Okay, these are the sign convention. Okay, let's move further now. Let's talk about the mirror formula. As you can see here, mirror formula is 1 upon V plus 1 upon U is equal to 1 upon F. What is U here? U is the object distance, means the distance of object from its pole. is called object distance, and V is image distance. Means the distance of image from the pole of the mirror is called the image distance. Okay. And what is for F? F, you have already learned that it is the focal length. FP is the focal length. Okay. So the formula is goes like this: 1 upon V plus 1 upon U is equal to 1 upon F. And this formula is valid in all the situations for the spherical mirrors for all the positions of the object. And remember, you must use the new Cartesian sign which you have studied in this slide, new Cartesian sign convention, while substituting the numerical values for U, V, F and R in the mirror formula for solving problems or numericals. Okay, and look at this table. This is the summary of what I have told you. U will always be negative because U is the U is the object distance, and object is always kept on the left side of the mirror. So it will be it will be always negative. And then V is the image distance. It is positive in case of convex mirror because the image formation is on the right side of the mirror, so it will be positive always. But in concave mirror, when the image is formed on the right side of the concave mirror, then the image distance, that is V, will be taken as positive. But when the image is formed on the left side of the concave mirror, then the image distance will be taken as negative. Okay. And focal length of the convex mirror is positive and focal length of the concave mirror is negative. Okay, please remember this. This will help you in solving the problems. Okay, now there is another term called magnification. Magnification produced by the spherical mirrors gives the relative extent to which the image of an object is magnified with respect to the object size. It is expressed as the ratio. It is expressed as the ratio of the height of the image to the height of the object. Okay. So height of the object. So if, let us say, if the h1 is the height of the object and h2 is the height of the image, then the magnification m produced by the spherical mirror will be h2 upon h1. Okay. So and the magnification m is also related to the object distance u and image distance v. It can be expressed as m is equal to minus v upon minus v upon u. So you will get a new formula that m is equal to h2 upon h1 or m is equal to minus v upon u. Okay. Now these are some points which you should remember while describing the nature of the image and the size of the image. If magnification is greater than 1, after calculating magnification, the value is greater than 1, the image is bigger than the object. If value of magnification is equal to 1, then image is of the same size of the object. If magnification is less than 1, then image is smaller than the object. Okay. Now, if the value of magnification comes in positive, then please remember the image is virtual and erect. If the magnification value is in negative, then the image is real and inverted. So, dear children, please remember all these three slides. They are very important. First of all is the sign convention. The sign convention which you should follow while solving the numericals. Then the mirror formula. Then this table is very important. So remember uh, this also, and then another formula, that is magnification formula, and the points to ponder while calculating magnification. So thank you and have a nice day. We will be meeting you again in the next session.